Let's solve x squared minus 10x minus 4 equals 2. Same deal with that minus 4 on the left side. That's, I think, visually being distracting, so let's just undo that minus 4 by adding 4 to both sides. We'll have x squared minus 10x equals 6. Now the linear coefficient, the number just in front of x, is negative 10. It's a little strange that that number is negative, but let's just kind of roll with it, see what happens. Half that number is the second stick, so in this case, the second stick is negative 5. Now, if you square the number negative 5, that's negative 5 times negative 5. That'll be positive. That'll be positive 25. So, I don't know if this is going to work, right? But let's just give this a try. Let's add 25 to both sides. And you'll have x squared minus 10x plus 25 equals 6 plus 25. The left side actually factors. You can check. If you do x minus 5 times x minus 5, that will be x squared minus 10x plus 25. So we really do have a perfect square. It's a little strange with that minus sign, but we're just going to roll with it. On the right side, 6 plus 25 simplifies to 31. Square root both sides. Don't forget your plus or minus sign on the first step where square root symbols appear. The left side simplifies because the square root and the square symbol undo each other, so you have just x minus 5. And then on the right side, we still have plus or minus root 31. And then we'll just need to add 5 on both sides, right? Since the left side said x minus 5. So if we add 5 to both sides, we have x is equal to 5 plus or minus square root of 31. Some comments? Just recall the linear coefficient is the number in front of x. Don't include the x. The x just tells you where to start looking, and then look in front of it. So the linear coefficient is negative 10, not negative 10x. To get the second stick, we took the linear coefficient and we divided by 2. We got negative 5. I mean, that number is negative, right? We took that second stick. It was negative 5. Square it. Get 25, which is positive, since squaring a negative results in a positive number. It's kind of strange to say that the second stick is negative. It doesn't seem to fit, the geometry to say that the stick length is negative, but at least in terms of the algebra, things seem to work out. So we'll just go with it. Let's try another example. X squared minus 6x plus 1 equals 21. Again, there's this plus 1 on the left side. I think it's just kind of getting in the way, so I just would like to subtract 1 to start on both sides. And then linear coefficient negative 6, half of that is negative 3. That's the second stick. Take the number negative 3. We've got to square that to get the number 9. So 9 is the constant that we need to add, and we'll add 9 to both sides. So if x squared minus 6x plus 9 is equal to 29, the left side does factor as x minus 3 quantity squared. The right side will just still keep as a 29. Oh, I think I should also point out here that on the left side, it really is still x plus second stick quantity squared. So it's x plus negative 3 for the second stick, which we just write as x minus 3. So even that all works out. Square root both sides. The left side simplifies to x minus 3. The right side still a plus or minus root 29. Add 3 to both sides. You have x is equal to 3 plus or minus square root of 29. Okay, yeah, so here's that comment, right? So the left side still factored as x plus second stick quantity squared. It's just we would write that as x plus, and then still using a blue background for second stick, negative 3 quantity squared. And then instead of writing x plus negative 3, you could, of course, just write that as x minus 3. Interactive question. So noting that the second stick is negative, in this example, negative 3, someone decides to add negative 9 to both sides. Explain why this doesn't work. For example, you could talk about what goes wrong when you try to factor x squared minus 6x minus 9. Let's take a look at x squared plus 5x equals 7. Now, there is no worry about a constant on the left side. We've been doing a couple examples like that, but we don't need to start by adding or subtracting a number so that there's only 2 terms on the left side. So let's get started with looking at the linear coefficient and the second stick and that sort of stuff. So first of all, the linear coefficient is 5. Half of that, second stick, is 5 over 2. So the second stick is 5 over 2. And then, for the constant, we need to square 5 over 2. So the constant to add is 5 over 2, quantity squared. Here's where the formula up at the top right, one of them anyway, the first one, is going to be helpful. So a over b quantity to the kth, we have a formula that says that that's going to turn into a to the k over b to the k. So we have 5 to the 2 over 2 to the 2, or 5 squared over 2 squared. So 25 over 4. So the simplified form of the constant to add to both sides is 25 fourths. So let's do that. but before doing that, let's just draw a picture here that the original left side is x squared plus 5x. So here's a picture of it: x squared plus 5 halves x plus 5 half x. But then it's missing this piece in the lower right corner. That missing piece should be 25/4. So it still works even if it's a fraction. It all works the way it needs to. We are going to take x squared plus 5x equals 7 and add 25/4 to both sides. Okay, that's what we're going to do. Just also keeping in mind, just remember that the second stick was 5/2. Okay, so let's just copy that info. We had already noticed the second stick was 5/2. We know we need to square that number, which was 25/4, and that's the number, 25/4, that we need to add to both sides. So here's what it looks like. It's a little messy. X squared plus 5x plus 25/4 equals 7 plus 25/4. Now this is going to factor. So on the left side, it's going to be x plus second stick quantity squared again. It really is. And you should check that x plus 5 halves quantity squared will become x squared plus 5x plus 25/4. On the right side, we have a 7, which is not a fraction, and 25/4, which is. So let's think of the 7 as 7/1. Start creating a common denominator. So 28/4, right, plus 25/4. So that should be 53/4. Now square root both sides. The first step in which square root symbols are written needs to have a plus or minus sign. And then on the left side, you can undo the square root sign with the square. And well, we won't do that yet. Just let's use the other new formula. That the square root of a over b is equal to the square root of a over square root of b. So on the right side, root. So the plus minus sign's already been copied, but then root 53/4 becomes root 53 over root 4. And then on the left side, we can take care of the square root and the square, undoing each other. On the right side, the only change has been root 4 has been simplified to a 2. Root 53, nothing really happens to that. And then to solve for x, we need to, it says x plus 5/2, so we need to subtract 5/2 on both sides. So x equals negative 5/2 plus or minus root 53/2. Just be careful that the over 2 is not inside a radical. This is fine as a final answer, but so is this. So if you want, you can say, look, we're adding or subtracting fractions with a common denominator, so we could stick it all in one as well. This is our first example where the linear coefficient wasn't an even number. We had the number 5. This led to the second stick 5/2 being a fraction, and it's more tedious to work on fractions, but being consistent actually worked out for us.